So we want to get to a point talking about instantaneous rate of change, which is very much in the name, this idea of how are things changing at an instant, at one moment in time. Before we do that, let's review average rate of change, which is kind of over a period of time. On average, what kind of change did we experience? Did we experience an increase or a decrease? By how much or how little? So this ties to the idea of slope. So the slope is considered the rate of change between 2 points. So notation that we've used previously for slope, we use the the letter m. And then what we would do is if we have two coordinates, say we have an x1, y1, and then a second coordinate, x2, y2, then what we would do is in the numerator, take the difference of the y values, and the denominator, take the difference of the x values, making sure that you're kind of lining up. If you're doing the second coordinate first, then if the number 2 coordinate is first, then the number 1 coordinate would be second in terms of the subtraction. So then we can talk about average rate of change, which is the same idea of slope. It's just a kind of different name to it. So average rate of change, or AROC for short. And that is the slope of the secant line, is what we'll call it, between 2 points on a function. So this notation here for our average rate of change is really the same as up above. It's just using our function notation. So it's like we have a coordinate where the x coordinate is a, and then the y coordinate would be the function output, so f of a. And then our second coordinate, we would have x coordinate of b, and then the output would be f of b. So it's still this difference of y coordinates over difference of x coordinates. We're just using a and b to kind of signify the beginning and end of the interval that we're looking at. So let's take a look at this and get this idea of what a secant line looks like in terms of a graph. So here we're given the function f of x equals x squared plus 2. So up above here we have our graph. So x squared is our parabola, and then that plus 2, that's what bumps it up 2 spots. So we have a vertex at 0, 2, and then that parabola is opening upwards. And we want to find the average rate of change from x equals 0 to x equals 3. So if x equals 0, then we're at that coordinate 0, 2 on our graph. And then our second coordinate is when x equals 3, which is up here at the coordinate 3, 11. So we have our 2 coordinates, and the secant line is the line that goes between those 2 points. So if I graph a straight line between those coordinates 0, 2 and 3, 11, that right there is the secant line. So the secant line is specifically the line that goes through 2 coordinates on a function. So we have our parabola doing its own thing, but then if we get this linear function to kind of go through our original function, that's what the secant line is. So let's just label that. That right there is the secant line. And then we have our 2 coordinates, so we have 0, 2 and 3, 11. So the slope of that secant line, or that line going through the 2 coordinates, is our average rate of change. So we're getting this idea of overall, how did our function change from 0 to 3? So we can see from the lines there was quite an increase from a y of 2 to a y of 3, but let's actually calculate this. So we have the coordinate 0, 2, 3, 11, and to calculate average rate of change, we're going to take the difference of the y value, so I'll go 11 minus 2 over 3 minus 0. So I'll be a 9 over 3, which simplifies to 3. So on average, we had this increase of 3 per 1 unit. Since there's no units of measurement here, can't get much more specific than that, but we'll look at some applications later. But average rate of change is a positive 3, showing that it increased. So let's look at that same function, but let's look from x equals negative 2 to x equals positive 1. So with this, my secant line's going to change. So I'm going to get rid of those coordinates that I drew before. And at x equals -2, so we have this coordinate -2, +6. And then x equals 1, so we have the coordinate 1, 3. And the secant line between those two is if we just connect those two dots with a line. So we still see our parabola. It's just a straight line going through those two coordinates from f of x. So we have our secant line, and our average rate of change is the slope of that secant line. So -2, 6, 1, 3, and our average rate of change, we'll take the difference in the y value, so 3 minus 6 over 1 minus -2. So let's see, 3 minus 6 is a -3 over a 1 plus 2, which is +3. So we're seeing a slope of -1, which if we go back, that makes sense. We can kind of see visually this line is decreasing by 1 for each unit. So overall we had a decrease in our function between those 2 points there. So that's the idea of average rate of change, working with a function, and then given this beginning and end value, so like a and b, where here we had 2 x coordinates, we take those 2 coordinates from the function and find the slope between those 2 points.